Hey everybody, welcome to part 3 on our series on PCB Design. In this episode we're going to start talking about part placement, where we actually put things on our printed circuit board. I'm going to show you some tricks with geometry so we can center parts and get things exactly where they need to be. We'll also look at how we can improvise parts when we don't find them in our clip bin. We'll also start running some traces and look at some of the problems and issues that come up with that. But first, here's this from our sponsor. Well, let's get started here. You're going to see exactly now why I went to all the trouble to create this virtual breadboard with all these spaghetti wires. And that's because when we switch over to the PCB view, you'll be able to see that we have on this view all these dashed lines. We call these a rat's nest, and they show us the same connections that we made on our breadboard version. So to start out with, I'm going to move some of these things around. They're all pretty much stacked up here. Let's just start peeling them off and getting them here. We'll take our resistor number 1 and put it down there. And then we have a whole bunch of parts that, because we duplicated them, they all ended up here in the center. I used the mouse wheel to scroll in and out, so there will be things that you see happening on the screen that might not be obvious. But I'll click over here. We've got some headers, and I'll just start pulling them off out of the way here. They're layered on top of all of my resistors. Now, here's my resistor. This is R2. I'm just going to set it next to R1. There's R3. I'll just pull all of these off. Just kind of open up the space. And the first thing we're going to talk about is the size of the printed circuit board itself. If I click on this printed circuit board over here, you'll see that the size is displayed down here in the inspector. And I need to make room for those 2 panels. So I've already done the math on this, and I know that the size I need will be 156 millimeters by 45 millimeters, and you'll see when I enter those that the size, I'll scroll back for you, the size of our printed circuit board here has changed. There you can see the whole thing on the screen, and that represents the size of the board that I want to create. Now you notice that when we were working on the breadboard that we have these 2 fairly large digital display panels. I need to know one way or another how to represent those here. And so I'm going to do a little trick. I'm going to go into my parts bin over here and pull this down, and I'm just going to bring in another printed circuit board. A second one. So I'll make this second printed circuit board the same size as that digital display panel. And I've measured that panel. I know that it is 72 millimeters wide and 26 millimeters high. So we have just a representation of what one of those panels looks like. And I'll use this that will allow me to kind of display things in Fritzing, so when I work around it, I know where things are. When we actually submit the order, this panel, I'm going to create a second one just like it, will be deleted. It's simply here so that I can eyeball it and get things in the right place. Now, I'm going to show you a technique that I think will be helpful, a clever way of positioning this new panel, the dummy panel, in the right place. There will be 2 of these panels, and I want them to be centered on the real PCB. So I'm going to take this PCB, I've highlighted it here, and I'm going to go down here and I'm going to cut this in half. So what we need to do is take half of 156. So I'm just going to make this 78 instead of 156. That gives us the ability to line this guy up right there in that position. I could do the same thing if I want to go vertically. I could eyeball it, but if I want it to be actually dead set in the middle, I'll show you how I can do that. We'll take this board and cut it in half again the other direction. So half of 45 is 22.5. That'll bring that up there. Then I'm going to take the panel and we'll cut it in half as well. Half of 26 is 13. And now all I have to do is home in directly on this corner and line those guys up just like that. So basically we're looking at halves of our boards. Now I'll just go back and put the real dimensions back in, put the 26 back. We'll come over here, we'll put the 45 back, and then finally we will put in the 256. And now you'll see that I have successfully positioned this panel right where it needs to go in respect to the other PCB underneath it. But we need two of these, so I'll just select that one right there. I'm going to duplicate it. You can duplicate things from this edit menu here, but you'll notice that I will duplicate throughout this whole project by using Control D. It's a quick way, it works real fast for me. So we now have a second board in there. I'm going to move it in position and get it just lined up like that. Now that's a pretty clever way to just ballpark this thing into place, but let me show you something here. This is the panel that we want to be able to put on that printed circuit board, and it comes with these real long leads right here. They're much longer than what you would normally expect to see, and we will have it elevated just a little bit above the printed circuit board for reasons that'll become obvious when we start to assemble it. And these pins that are on the panel are very small compared to the typical size holes that we will have on our PCB. If I put this in here onto this proto board, I put that in there's room for this thing to move around quite a bit. So it'll be easy for me to align these two panels and get them completely straight with each other and bumped up against each other exactly the way I want. So the effort that we're taking to put the dummy boards in here and position them is pretty good. Oh, look there. I entered the wrong number. It shouldn't be 256. It should be 156. Much better. Okay. Simple enough. Now that I've got these three boards positioned where I want them, I'm going to lock them so that they don't move. And I can do this multiple ways. There's one way to do it there. I can right click on the board and lock the part that way. This is a convenient way of locking them so that they can't budge. When I'm dragging other things around, if I accidentally miss what I'm pointing at and pull on the wrong object, these will stay put. Now, one of the things that we have to watch out for here has to do with the fact that when this project is finished and I have my digits attached to the printed circuit board, I'm going to attach them to the back side of the board. All of the components, the resistors and the ICs, will be on the top of the board, the front side of the board, but our digital displays are going to be located on the back of the board. And that means that the way it looked when we put it together, I'll show you here, on the breadboard, these headers right here were set to line up with the panel on top. We need to set it up so that it lines up with the panel on the bottom, which means that this J1, which was attached to, I'll rotate him here, which was down here on this panel, it needs to be over on that panel. So I'm going to move that there. J2, which I'll rotate and he's going to go over here somewhere. J3. Down here, J4. Will be up there. Now we have these two headers right here. Talk more about those in a bit, but I'm just going to get them out of the way and put them right down here for now. That's how those are going to go. The other problem we have is we can't just use the pins the same way we used in the breadboard because everything's on the back side of the board. We need to do a mirror image of those header pins as well. This is how I'm creating the mirror image of our breadboard. Okay, so that's that part. The next challenge is getting those pins in the right position for our displays. And we'll do some more trick geometry to accomplish that. Watch this. I'm going to mess around with the size of this dummy panel again. In order to do that, I have to first unlock it. But I'm going to take this panel right here and I'm going to cut it in half. Half of 72 is about 36. So we'll cut that in half. And now let me home in right here. And I'm just going to eyeball it. I'm going to put this guy up here, but we have a snap to grid turned on, which limits where I can put things. So I'll go into the view menu temporarily here and take this align to grid and turn it off so that I can move this around smoothly. And what I want to do is bring this up, align it with the top of the panel there, and then just center this middle edge between the two through holes there. I think I'll take this guy right here and do the same down here. Now that that's in position, I think I'll lock him. And then I will move up here and lock that part as well. Then I'll come back to this guy and I'll put him back at 72. And we can lock it. So that means that those headers, scroll back, those headers are in the right place. I feel comfortable with where they are. We'll do the same thing with the other panel. Speed up the video and you can watch me do it. Very good. So you can see here we're getting these well into position. They're locked down. That part of the task is taken care of. Next, I'd like to label these pins so that we can keep track of which pins do what. When you look in the parts bin over here, you'll see that Fritzing gives us the option to bring in text. We can put text right on our printed circuit board. This would be a silk screen. We can type anything we want in there. And so I'm going to label the pins with the same letters that we've been using with our segments. And I'll do that by typing down here in the inspector the letters that we want. B, 3, 2, F, A, and 1. And I'll push enter there. And I'll bring this over here. And it's much bigger than the spacing on my pins, so I just simply grab this corner here and I'll do a little bit of adjusting until it lines up like that. And so there we have that in place, but guess what? That is in the wrong spot. It needs to be on the other side because we're looking at the mirror image of our board. So let's just move him over there. And now I will make another one from here. I'm just doing Control D to duplicate it. And this will go right there. And it's the same as the first one, but the numbers which represent the cathodes are going to change. So this 1 will become cathode 5. This 2 will become cathode 6. And this 3 will become cathode 7. Basically, we're just adding 4 to each of them. The anodes, the A, the F, the B, they all stay the same. So let's take care of the bottom pins as well. So we've labeled those, and that will come in really convenient as we're laying things out, and we want to make sure that all our parts are lighting up the right segments of our display panels. Now let's zoom out and see what some of the other things here are. You'll see down here we do have our Arduino. I might move this around and bring it down here. Let's rotate it around a little bit. And then, this header. These are the pins that go to the Arduino. And I want them on both sides of the board, and they will do the same thing. And so I'm just going to link these. If you notice, what I'm doing is I'm simply double-clicking those traces, and it puts these traces on there. That's actual copper. It's putting them on the back side of the board. We'll be able to rotate them around and do them later. I think I might go in and change the width from standard to thin on each of those, which I think will be fine for this project. So you can see that I'm changing the thickness. You watch me. I will do this throughout the project on almost all of the traces, but I'm going to come back later when it comes time to run our 5 volts and our ground around. I'm going to go with thicker traces, so some of those will be switched back again. These will actually end up on opposite ends of our printed circuit board when we're done. One will be over here, one will be over there, and we can move them around. And you go like, well, what happens if you start moving things around after you put the traces on? And this is really cool. You see, we can move it all over the board. The traces will follow along with us, just as the rat's nest wires did. So that'll work out pretty good for us. We'll just leave that there for now. Now, a real important thing about doing a project like this in Fritzing or in any program where you're moving a lot of objects around and changing things is to save your project often. And I don't mean just save it again and again and again with the same file name. What you want to do is save it in increments. So if we completely botch something up, it's easy to get back 1 step or 2 steps along the way. So what I do is I'll come in here and I'm going to use save as, and here we have our file name, and I'm just going to come in here and put a .1 in there. So it's 8-digit board .1. That's saved. Now the next one that I work on will be .2, and we'll just progress along the way like that. I can always go back to that first step if I have to. Now let's do something with this U1 and our resistors. Let's zoom in a little bit here on our project. Focus on this part right there. I'll take U1. I'm going to bring it up into this area here. Just kind of rotate it, put it on its side. You'll see that there are a lot of resistors here that are going up to the various pins on this chip. If I click on one of these guys right here, it lights up the resistor down below that is attached to that. So I'm just going to grab that one, home in. You'll see it, shading will change when you get the right one. So we'll just put that one right there. You know what we didn't do? We did turn our align to grid back on. So let's get that going again. And that should make things come out a little better. You know, we didn't have it on when this one was moved either. There we go. That takes care of that resistor that goes there. Now the next resistor, see the light over there? We will just grab it. And I think I'll put it in kind of staggered here, like that. I can see this line coming right down here to that one. So we'll put that one in. We'll just staircase these. Now this guy is that one way over there, and it needs to be rotated. Okay, let's do some traces. We'll just get ourselves some room here. This guy right here, we'll just double click that And you'll see this creates a trace for us. I think I'll go down here and I want to move the trace from the bottom to the top. You see it change color there. And I'm going to make it thin. And we will just kind of give it a route like so that it goes into A like that. I will then go ahead and put the other end there. And we'll leave it on the bottom for now and make it thin as well. So that's done. Now I need to do R3. This guy, he goes to B. I'm going to put that one on the top as well. So I'm using the inspector over here to do that. Let's go thin on that. And now let's drag this thing out here for now. I'll go ahead and hook up all the traces for these resistors to our panels and come back to you in a few minutes. Notice here that after we have created a trace to some sort of a connection, that the circle representing the connection or the through hole on our PCB changes from this reddish orange color to a green color. So the green means it's good to go, I guess, and the red means it's still to be done. We need to stop and fix it, and that's really quite convenient. One of the things that you'll notice though is that we have run all of these current limiting resistors over to the headers on this panel here. They will also need to go on to the other panel. Let me scroll back here and I'll show you that if I come over here and touch on this guy, right, well, let's do it on the resistor end, it might be easier, that the G lights up on both sections. We need to run a connection between those two. So let's do that now. We have a whole pile of rat's nests right here in this line, and don't know for sure which one is which. So I'm just going to grab one and move it up, and you'll see that there it is right there. We'll change the thickness. I'm going to leave them on the bottom, and we'll run this one over to the decimal point. Maybe we'll put it right down there, and we'll grab the other part of it. There we go. And that'll go down here somewhere. So those are now connected. I'll go get another one and see where it goes. Change the thickness. We have two layers of the board to work with. There's a top layer and there's a bottom layer. And I can switch these layers on and off here like this, and you'll see some changes there. And what I think I'd like to do is have a plan whereby the traces that run predominantly horizontally should be on the top, and the ones that are for the most part vertically are going to put on the bottom. That will help me with the routing. So real quickly, I'm going to go through these traces here that I have just finished and switch them all to the top layer. And I can do that by right-clicking and just say move to the top. The next thing that I'm going to do is the same thing to these traces that connect the top two headers, just like I did to the bottom two. I'll speed up the video as we work on those. Our cathodes are driven by U2, this other shift register. Let's bring it up here. I think I'll rotate it around. We'll stick it in kind of this area here, and let's connect some of these leads up like we did to the other one. Sometimes when you're laying out the PCB, it becomes necessary to move a whole group of objects that you've already connected traces to, but you're not quite happy with where they're sitting on the board. Let me show you what I mean. Right here, looking at these resistors all down in this area right here, and the IC that's in here. I get the sense that this is not going to work out. I'm going to be just too far off base on my printed circuit board. They're not even on the board itself. I would like to move all of this here, kind of rotate it around and see if I can position it into this space. In order to do that, I need to select more than one object. So I'll do that. I'll click here on U1, and then I'm holding the control key down on my keyboard, and I will next select each of these resistors that are attached to it. I'll make sure that the dotted lines appear there. I'm not convinced I have that one there. We'll find out when we go to move it. One more. Come on, there we go. Now, if I take this guy and I move it, they're all moving except for that one resistor that I'm having difficulty grabbing. We'll move it manually, I guess. It doesn't want to join the group. Now I can rotate this, and I'll bring this up and kind of position it into this space here. This resistor over here is going to have to go someplace else. I'm going to stick him over there for now, maybe even rotate him. Put him close to his destination. This resistor down here, now it lets me connect to him. I'll rotate him and we'll grab him and bring him in like the others. So that's allowing me to move a whole group of them. Now the connections in the middle here are sort of all a bit of a hodgepodge, but we can sort those out. What I'm going to do is I'm going to start removing some of the bend points and get some of these traces to come. So if I come down here, for example, I right click on this and it says remove bend point, and then I'll do it again here, and I can shorten this thing and get a more direct connection to it. I'll go ahead and work on those, and you can watch. We'll clean up this mess. Let's work on the two headers that are going to connect our board to the outside world. We'll take one of these guys up here, and maybe you need to scroll out a little bit. I'm going to position him in here, see what we can do. I grab this one here. Let's just put it there. It's going to eventually go on the other side of the board, but I'm going to look at what we can do in here. And I'm seeing that we have these connections to make on our IC, and we've got some leads that are going to cross here. I think we might want to just change the order in which these leads are connected. We can do it here. It's just that when I did it on the breadboard, I didn't see how this was going to be a cross when we came to the printed circuit board. And it doesn't have to, because we can connect these 5 pins up here to our IC in any order we want, as long as we pay attention to what we're doing. So I think I'll go ahead and I'm going to right click on this, and I'm going to say delete that rat's nest. And it's going to start desperately trying to keep things connected here. As you see, new rat's nests appear, and we'll just go with that. We've got these three right here going down to the Arduino. I think I'll just delete those as well, and we'll just hook the thing up again later, and we'll get these in a more convenient order. Let's start by running this top pin over to this guy here. So let's just run that one right over there like that. And I think we'll put this one on the bottom. And I already see that we're going to cross this guy. So let's just move this one to the inside for now. There's another cross in there. We can sort that out later. The next one right here, we'll just run straight over to there, and Move that to the bottom. Run that one in there and put it on the bottom. And I'm going to leave it thick because it's a ground. And then that'll be our ground pin there. And then the next one down is going to come over here. This is our data pin. Put that in like that. Put them on the bottom. Make it thin. And finally, this last piece here, this has to go to our 5 volts. So we'll run that. It'll be a thick one also. Then we'll run it right there, but I'll put it on the bottom for now. Okay. So that takes care of those guys there. So we've just changed the order of those pins, which is fine. Now I'm going to take this guy. I'm going to move him all the way over to the other side. But before I do it, I'm going to come in and insert a bend point. So add a bend point on each one of these. And when you're going to like this. If I put a bend point on each one of these. Now when I move them around, see, I still have this guy coming out from there, which is convenient because I don't want him to flip over to this other side. And now I'm just going to use my mouse wheel and I'm going to come way out here. We're going to grab this guy, take him all the way around over there, put him on that side. Pretty crazy, huh? Now let's go back over here and we'll take these bend points and we'll start moving. So I'm just throwing them out here. Go over to the other side now. And we'll do kind of the same thing. We'll take we need to get our ground and our 5 volts up there to that terminal. If I look in here, we have 5 volts running right there, but I want to run it from here. So let's take this 5 volts down to there, and that pull this out of the way a little bit. That took out that extra rat's nest that we don't need there. And we'll do the same thing with ground. I got it connected to the wrong one. And then let's see, we'll run one from ground also. Ground is right here. Let's put it in to there. Those are like the leads that we ran from the Arduino over to our breadboard when we were working there before. This is probably a good time also to save our project again. And I'm just going to come in and call it number 2. We seem to have a lot of red dots over here on our YouTube. Zoom in on there. Let's see what we can do with this guy. Maybe some of these can be taken care of. Well, this should be ground, I believe, because it's a black trace. Yep, it's ground. I think I'll just go ahead and put that in. And then we need to connect it over to the ground on this side. I think I'll drag a line from there to there. Let's put it on the bottom. And we'll just kind of bring it up and out. For now, I'm going to get it out of the way. We can do the same thing with our 5 volts. Put that in there. Then we need to link it to this one here. So I'll just go like that. Bring this down. Well, that takes care of U2 for now. It seems to be okay. There is one pin here that has no connection to it. If we were to daisy chain a third shift register, it would be connected to this pin here, pin 9. We aren't, so that will always be empty. So that takes care of all of those connections. And look down here. It now tells us that routing is complete. That doesn't by any means mean that we're done. It simply means that all the connections that Fritzing thinks we should have are connected. There's no more rat's nest loose on the board that we have to hook up. So let's back off a little bit and see what our project looks like right now. We've got some work to do. We'll be looking at a lot of overlapping traces here that we will start to sort out and adjust. I think I'll go ahead and save one more time because now that our routing is complete, this is a good point to be able to come back to if we have to. Call it 3 and save that. I think we'll end this segment here. It's a good place to stop. We still got a bunch of work to do. In part 4 of our series, we'll look at vias. They'll help us solve a lot of those traces that are crossing each other on each side of the board. We'll also mess around with a tool that is our design rules check. It'll tell us whether any of our traces need to be moved one way or another. It's a great tool that spots our errors and points them out for us. I'll also take a little bit of time to show you how we can add an image, a bit-mapped image to the silkscreen layers of our boards. In the 5th part of this series, we'll create the Gerber files, upload them to JLC PCBs so that we can look forward to getting our printed circuits boards back in the mail. I hope you'll stick around and join me for those episodes as well. You should automatically move on to the next video. If you don't, you'll find it in the playlist below. And hey, don't forget to subscribe, like, and share.